Hello everyone. So today I wanted to go over the process I go through when building a custom amplifier. Now this will be a multi-part series. So let me tell you about the person that this will be for. This is for a good friend of mine, Scott. He's down in the 38 area of Florida, and he is a tremendously gifted and talented musician. I'll link to his Instagram down below. He's been kind of on his tone journey to find what really works for me. He's tried a lot of different amplifiers and none of them really work, but he knows the bits and pieces from different ones that he likes. So I'm going to take that information along as with my years of experience and build him a custom amplifier to suit his needs. So the starting point for this will be a Hot Rod Deluxe that he gave me, and boy, this thing's a doozy. A lot of people have been in it. So let me show you the starting point and we'll go from there. So this is inside the Hot Rod Deluxe that I got from him as the starting point. You can see someone's been in here. I've made sure that this is all safe. Someone has put all that together, electrical taped around, some caps with some hot glue on there. These are resistors that are known for going out in these amplifiers. You can see how discolorated this area is. So that's a common problem in these hot rods. And more glue over here. This capacitor is actually cut. I don't know if you can see it, but it's out of the circuit, and some extra wires running around there, more glue. And on the top, you can see with the Florida air, how it's all rusted up. But let me get this taken down to what we're going to keep. All right, before I put this circuit board in the trash can, I want to show you the back side of this board. This is where those two resistors are that I said go out on these amplifiers very often, and you can see the damage that it does to this. So this is very common with these hot rod amps. And here we go. All disassembled. No tube sockets, no circuit board, no jacks, no potentiometers. I'm going to hit this with a lot of sandpaper and wire wheel to get that all cleaned up. I will be relabeling it because the control layout is going to be completely different on this. So on here, keeping both the power, the choke, and the output transformer. For this, I am adding a reverb driver to this because he wants reverb on this amplifier. So let me get this set aside and I'll talk to you a little bit more about what type of circuit's going to go in here. All right, so you just saw how I disassembled that amplifier down and got it stripped to basically its bare bones. So the circuit that's going to go into the amplifier is going to be a single channel with reverb. Now the way it's going to be voiced is a lot of Scott's influences and music genres that he plays down in the 38 area kind of help dictate that it's going to be more of a Marshall kind of style voicing than say like a Fender style voicing. However, it's going to be more of a clean pedal platform, but still have the characteristics that Marshall kind of amplifier has as far as the mid-range, the bass, and the treble. So I hope you guys like and subscribe and stay tuned for more videos on this amplifier. And I wanted to go over the tone stack. The tone stack is one of the most critical parts of an amplifier that sets the voicing of it. It gives you the color palette to be able to paint with. One of the things that I look for in a good tone stack is one that kind of sets the voicing to where you're not having frequencies that are on the bass player's kind of side, one that kind of dips out the mids right around where a singer would be, and highs that are not really piercy, nice, picky, and sound awful. So there's different types of tone controls, let's say, in guitar amplifiers. One of the most simplest one is one that all guitar players are familiar with, actually. And it is the tone knob that is on your guitar. It's just a simple potentiometer with a capacitor, and it just rolls the highs off. And there are a lot of guitar amplifiers that use that. You know, Silvertones used it, and several of the other, say, more inexpensive amplifiers use it as well. Then you can get the more complex ones that have like a treble and bass control, treble middle bass, and then you can get into also active tone controls. So most of the ones that guitar amplifiers have are passive tone controls, which means they cannot add frequencies, they can only subtract frequencies. Now a good example of a active tone control is one that is right behind me on this Mesa Boogie, where you've got the active EQ. So let's go to the computer and look at tone controls and see how they work and see how we can modify one to make it act in the way we want it to act. All right, so I have here a online tone stack calculator just to kind of help visualize what's going on. So this is for a Fender treble middle bass tone stack. So this is very similar to one that's in the AB763 circuit. So may not look 100% familiar if you've looked at a schematic before, but here's your treble control, bass control, and then this is a deluxe reverb, so it has a fixed mid resistor here. You have different capacitors here, treble, bass, mid, and the slope resistor. And we have that laid out. There's your treble cap, mid bass cap, and mid cap, and then treble, middle, bass, controls, and slope resistor. Now the slope resistor, a lot of people don't know what it does, but it basically sets the amount of volume that is going between the treble control and the mid and bass control. So the higher this is in value, the more higher frequencies you will have, because that's allowing more to go to the treble control versus the mid and bass control. So now let's look at the graph of the Fender tone stack. And so one thing to kind of keep in note here, so this is your frequencies down here. The low E string on a electric guitar tuned E standard is 82 Hertz. So that's right here. So one thing you'll notice is that this is boosting frequencies well below that. And if we go over here and use this, you see it's acting on a lot of frequencies that are too low for a guitar. Now, if we set the mid control to about 6.8, which is where it is in the deluxe reverb, you can see how much of a mid dip there is, and this is right at 49 Hertz, where most vocal ranges is going to be up a little bit closer to 1 kilohertz, and then the highs here. So one thing we can do is just take a sweep, and you can see all of the different possible combinations here of that tone stack. So let me show you the Marshall one here and how this is kind of boosting the frequencies here right where we need it to be to ensure we have tighter bass. That way we're not in the range that a bass guitar would be in, but we're right in the range where the electric guitar low E string is. This mid is bumped up to about 700 Hertz. So that's a little bit more where it's cutting to where you're not getting in the way of the vocalist. And this is still about the same. Now, one thing you may notice is that all of this is a lot higher in the graph than this is. One of the reasons for that is the value of these potentiometers here. Now, on the Fender, the treble and bass is 250K, and the mid control is 10K in like a twin or a super, or 6.8K fixed in like a deluxe reverb. Now on a Marshall, the treble control is 220, bass is 1 meg, and then a 25K for the mid control. So you add all these up, that's a lot higher resistance than the Fender. So that kind of helps force more signal out of the tone stack to where you're not losing it all to ground down here. So that's one of the differences between the Marshall and the Fender. So this isn't quite 100% where I want it to be. I want this to kind of sit a little more between, the super bass and the super lead. This has got the super lead values in here. So if we change the treble capacitor to something in between, say about 330, and apply that. So that moves this up a little bit more to about 840. So we've got that. So I want to have a little bit more of the highs here. So I'm going to up this to 47K. So that brought this down a little bit more high. So it's a little bit more even here. We just have the tone control set at 50% here. One other thing I want to do is adjust the bass potentiometer, the bass control. 1 meg, one problem with a lot of Marshalls, you kind of have this light switch effect that where, you know, down here there's nothing, then all of a sudden it just jumps up to that. So if I take this down to 500K and apply that, so that lowers that down a little bit. And one thing else I want to do is something that Eddie Van Halen's Marshall actually has. Instead of a 25K mid, it's 50K. So that allows it to be a little bit more of a flatter response. So if we do a sweep on this mid bump, yeah, it's a little low in some areas, but it's not extended completely out like the Fender was, to where we're rolling off these frequencies that the bass player is in. These frequencies are a little bit closer to more where the vocal range would be, and nice high end, and we have a lot of signal that's coming out of here versus the Fender one. So these values of a 330 picofarad treble capacitor, 220 nanofarads for the bass and mid, 47 for the slope resistor, and then these values for the potentiometers is what I'm going to go with for Scott's amp. I wanted to go over the preamp design, some considerations when selecting components and their values. We're going to be mainly dealing with the 12AX7 tube type, which is predominantly found in guitar amplifiers these days. So I want to go over, you know, how to control bass response from the preamp by different values, how you can set the overall gain of a preamp stage. And by gain, I don't necessarily mean distortion, but how much the signal is amplified. And there are a few different components you can tweak to adjust that. So let's go over to the computer, and I'm going to show you an online calculator and some schematics to give you an idea of what we are looking at. All right, so I wanted to start with the AB763 schematic and kind of show you the lay of the land on reading a schematic and what some of the parts are. So this tube right here, this is half of a 12AX7. A 12AX7 is a dual triode. So inside each 12AX7 is 2 gain stages, and triode tri is 3, the plate, the grid, and the cathode. So for this to work, you need a plate resistor. Typical Fenders is 100K. This coupling capacitor. So this coupling capacitor will block the direct current coming here and only allow the AC guitar signal to come through. Then you need a cathode resistor. So pretty much all preamps and guitars are all cathode bias. You may hear that from power tubes, whether they're fixed bias or cathode bias, but generally speaking, all guitar preamplifiers, those stages are all cathode biased. And on this one, it has a bypass capacitor on it. And in a little bit, I'll get into what this does and how you can use this to tweak the settings on it. Now, you may see this resistor here is 820, but it's shared, so it actually ends up being relative 1.5K, which is typically what you would see. You do also have to have what's called a grid leak resistor, and in this case, the master volume is being used for that. But you will see that like this 1 meg on the input stage is used for that as well. So looking at a different animal, the JCM 800, You see that this stage here, now it's kind of hard to read, but you got your plate, grid, and cathode here. Plate resistors up here, 100K, and down here it's just an 820, but there's no capacitor across here. The JCM 800 also has what's called a cold clipper stage. And that is this tube here, where you have your 100K plate resistor, 0.22 coupling cap here. But then you have a very large 10K cathode resistor. So this will bias the tube extremely cold and cause asymmetrical clipping where the waveform is not symmetrical on both sides, where it'll clip only one side of the wave. So on this calculator online, this is generally what we saw, where we've got the grid leak resistor here, plate resistor, coupling capacitor. This is the load on the tube, RG here. RL is the plate. And then RK is the cathode resistor. And then CK is the bypass capacitor. So when we get in here, this is already set for that Marshall input stage here, which is 100K, a 2.7K, and a 0.68K bypass capacitor. So this is the output here of the wave, and you can see that it's rolling off a lot of lower mids and bass, and that is due to the size of this capacitor here. So what if we change it to a typical Fender 1.5K cathode resistor, 100K plate resistor, and change this to a 25? Now you can see one of the things about Fenders that give them that bassier sound is just how much low end we now have in this amplifier. So you can see it does start to roll off a little bit right around the low E. In fact, this online calculator has that here. And you can see the overall gain of the amplifier. So one of the things I like to do is to use a smaller value, say 5 microfarads. And this rolls off more of the lower end here, but you still get to keep all of your mids and such. So now one other thing to kind of take into consideration is the value of the plate resistor and the cathode resistor. Now there's a ratio that I like to stick with that has been taken from amplifiers that I've been in, and several other boutique builders also use this particular ratio. Generally speaking, the higher value of the plate resistor, the more gain you will have, and we'll see that here, but you will start to lose higher frequencies. So if we change this from 100 to 220, and then the cathode resistor to 3.3, so gain at 10 kilohertz here is 35.46, and now we change it, now it's 37.42. So pretty good increase in the amount of gain. But also you can change it to 150 and say 2.2 and 36. So you can see you can play around with these values to be able to get different characteristics of the preamplifier. So lastly, I want to talk about why you need that cathode bypass capacitor, or why you may not need it. So right now we have the typical Fender values here, and we see that we have an overall gain of 35.46. I can take this and put it to 0, and now we're at 29. So we've lost a lot of gain. However, you can see that the frequency response is completely flat. So this may be good for like a hi-fi type of amplifier, but when we're dealing with guitars, we do need the additional gain to push things through, like a tone stack or effects loops or reverb drivers, reverb tanks. So we need more gain, and more gain is more distortion, and everyone loves distortion. So that's one of the reasons why this is very important. So these are all things that I am taking into consideration when building Scott's amplifier. If you guys have any questions, please put them down in the comments, like and subscribe. Thank y'all. Hey y'all, so today I want to start on the turret board for Scott's amp build. And one thing I wanted to cover was mil-spec wiring. That term gets thrown around a lot, but generally a lot of people don't understand what it actually means. So I'm going to put up on the screen the actual document that defines how you should do soldering and wiring on a turret board for the mil-spec. And one thing you will notice is that it states that the wrap around the turret should be at least 180 degrees and cannot overlap the other lead. So I'm going to show you that on the board. All right, so we have two capacitors here in the two turrets. So what they mean is at least 180. So wrapping this around. So at least 180 degrees and cannot have overlap. So basically right about 270 right there. And the same for this one. Wrap it around at least 180 and then cannot have overlap. So that's about right there. That is mil-spec wiring. Now to solder this on. So some people will take these leads and wrap it around these turrets several times. That's not mil-spec. The point behind mil-spec is not actually because it's a more secure connection, but because it's easier for disassembly. That way you don't have to get a pair of pliers and, undo this or clip this off and have to worry about what's wrapped around there. And so you can heat this up and just yank this capacitor off and be able to put another one on real quick. So think of, being in a battle zone, forest of Vietnam, trying to repair a radio to communicate. You don't want to fight a whole bunch of wraps around this. So if you like what you see, please like and subscribe. Let me know if you guys have any questions. Thank you. Hello everyone. So I want to go over the final video here in the building an amp for Scott. That is Hot Rod Deluxe. So here we have it all finished. Let me show you the controls here. So we've got the input jack with a guest jack. It's not hooked up. Volume, treble, middle, bass, reverb, master volume, presence, and then this double stack here is send and return for the effects loop. And then jewel light, standby, and power switch. So the two outside mini toggles here are bright switches. So bright switch on the preamp volume and bright switch on the master volume. Now the two here in the middle, those allow you to swap between different tone stack configurations. So as an example, both down, that's more like a Bassman JTM 45. This one up is like a Plexi. This one up and this one down is my version that you guys saw me design. And then if you go both up, it's more of like a rectifier tone stack. So let me do a little bit of a sound demo for you guys. And it'll be one clean and then one with the amp overdriven.